Attend.
Uh,
10. Do you
yeah.
know organic? Do you know organic chemistry?
Yes.
Okay. What do you know about? Did you watch the videos, guys? We need to watch those videos ASAP because I need us to understand this topic. It's very very important, right? Did you watch the videos? Okay. So with Easters, right? With Easters, I said that the structure will be something like this, right? I think I said something like this. Yes, I said the structure is something like this, right? And then that was my mistake, right? That was my mistake. That was my mistake because on the ester here, it is not supposed to be an alcohol. It is supposed to be a. It is supposed to be an oxygen, just an oxygen, right? It has to be an oxygen. So that's my bad, right? It has to be an oxygen here, so that it has to be something like this, right? It has to be like this. So there it is, right? There is the Easter, right? There is the structure of Easter, and when we name it, we start with it. We don't start with this part here that have got an alcohol, right? We start with the part that doesn't have this oxygen. So we start with this part here. So this part is 1, 2, 3 is propyl, right? So we're going to name this propyl, and then this one is 2, which is eth. So it's going to be propyl ether noate. All right, so there we are. So when I said it yesterday, I made a huge mistake. I said this one here, I said this part here is supposed to be like this, right? Which is not correct, right? So that is the mistake that I did yesterday. It was supposed to be only oxygen here, and then this one was not going to be able to be there because all the bonds 1, 2, 3, 4 was going to be formed. So there was no need for the other hydrogen, right? So this is the correct ethyl propanoate, right? This is the correct ethyl propanoate, right? So that is the only small mistake that I did yesterday. Is on video number 3, right? It's on lesson number 3 on the videos that I uploaded, right? So that is the only mistake that I've made, and then that is very very important, right? That is very very important. So before we go to reactions, there is some few things that I also need us to look at, right? And there's also some few things that I want us to look at, right? There is also some few things that I want us to look at. Just from video, this one here, I want us to understand the presentation of organic compound, which we have done, but I want us to look closer into it, right? I want us to look closer into it. Presenting organic compounds, we use a variety of ways to draw or write organic compounds. We either make use of molecular formula, condensed formula, or we use full structural formula. All right. So what is the molecular formula? The molecular formula does not show any bonds, only the number of each atom present in the compound, like CH3, C3H8. So if you have got C3H8, it is very confusing. You cannot exactly just tell what compound is it. All right, you cannot tell. Okay, CH3, C3H8 is straightforward. Yes, that is. There's no way it can have a branch. That is straightforward. Propane, all right, that is straightforward, propane. But C4, see, this is CH3, this is propane, right? And then there is this other compound. If the compound is written like this, C4H10, you cannot easily just conclude. Someone can conclude that this is going to be what? Someone can conclude that this is going to be butane, right? Someone can conclude that this is going to be butane because of the formula CnH 2n plus 2. Someone can conclude that this is butane. But let me show you that sometimes it might not be a butane, because if it's a butane, then it's going to be 1, 2, 3, 4. All right, it's just going to be like this, right? So that is our butane, right? that is our butane. You can see that 4 oxygen, 10 hydrogens there. All right, and then sometimes it can be something like this: 1, 2, 3, and then 4. All right, let's see if we're still going to have 10 hydrogen and like this here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. All right, so you can see that this one here is very different to this one. They are exactly different molecules, right? They are different molecules. This one is butane, yes, but this one here, it have got a branch, right? And then the longest chain is 3 carbon, so the parent chain is going to be propane, right? It's going to be propane. The parent chain is going to be propane, and then the branch is going to be methyl, right? It's on carbon number 2, all right? So this one is 2 methyl propane, right? So you can see that they are all C4H10, all right? And this one is also C4H10. So this one is different, right? They've got the same molecular formula, but different IUPAC name and different structural formula, all right? So they are different things. The only thing that is the same is molecular formula. Same molecular formula, different name, different structure, all right? So that is what we have to understand about molecular formula. So those things are isomers. We'll talk about isomers in this lesson, but now I just want you to understand the molecular formula, different between molecular formula, condensed formula, and structural formula. And then now we go to condensed formula. This formula does not show all the bonds, but shows the important bonds and general structure. All right. So for an example, they show us that it is showing us that the first carbon there have got how many hydrogen? It have got 3 hydrogen. That is very important, right? And then the carbon there, the second carbon have got 1 hydrogen. And then the carbon-carbon bond here is going to have two um bonds, right? So let me just put it down there so that we can talk about it while we see it, right? That we can talk about it while we see it. What's going on now? Okay. Yes. So you can see that here they do talk about the carbon-carbon bond here. All right. We've got carbon-carbon bond there, and then after this carbon-carbon bond, then there is another carbon that have got 2 bonds. So here I can name this one. I know that the first one here I've got 3 carbons. The second one I've got 3 hydrogen. The second one I've got 1 carbon, 1 hydrogen. The last one I've got 3 hydrogen. Usually the last carbon must have a Usually, the last carbon must have a 3 hydrogen, right? The last carbon must have 3 hydrogen. So why does it have 2? It is because there is a double bond, all right? So what is the name of this compound? The name of this compound is going to be, or the molecular formula of this compound is going to be C3H6. So it's a propene, right? Because of this double bond. So if I'm to write the structural formula, it's going to be C, and then C, and then C, and then the double bond, and then here there is the 3 hydrogen, there is the 1 hydrogen, there is the 2 hydrogens, right? So there is our propene, right? There is our propene, all right? So this one here, sometimes they will give you something like this. They will say CH3, and then they say C, they put a bracket here, they say CH2, and then they put a bracket here, and then they say 3, and then they say C, and then they say C, okay, let's say CH2, and then they say what? And then they say, let's say CH3, yeah, let's just end it here, all right? What does this say? It means that We've got CH3, CH3, and CH3. This has to be the end carbons, right? This has to be the end carbon. So I've got CH3 here, and then in between here, I've got 3 of CH2s, right? 3 of CH2s, so it's going to be C, and then 3 of them, right? 3 of them. Then the last one, which I've got 3 also, so this is the last one. So this one in between, there's 3 of them, all right? So just be careful of that also. They might give us a structure like that, all right? And then remember, when we talk about O, we can have OH, or then we can have C, with going to be like this, right? So this one here, you have to be very careful. Like for an example, if I've got C, H3, and then C, H2, and then COH. Right? If I've got something like this, and then I've got something like this, CH3, CH2, and then COH2. So this is very different, right? This is very different. You can see that the first one here, the main focus is going to be the first one. The first one is going to be the carbon. So for this is the first molecule, this is the second molecule, right? So for the first molecule, I can see that I'm going to have C with 3 carbons, and then C with 2 carbons. Obviously, it has to be in the between. And then the last C here, I've got O and H, all right? So you know that O can have 2 bonds, all right? Can have 2 bonds or 1 bond with hydrogen. If it have got 1 bond, it's going to be OH here. So you see, these carbons still need 2 bonds, so they were not there. So it means that I didn't do the correct thing there. It means that, don't know why it keeps on going up there. It's because I don't have a pen, all right? I need to fix having a pen, okay? So it means that it's going to have double bond of O and then H here. So this is the structure, all right? This is the structure for first molecule. First molecule is not an alcohol, it's an aldehyde, all right? But this one here, let's look at it. Okay, yes, okay. So the last one, I think it was supposed to be 3 here. Yes, it's supposed to be 3 there. Yes, just to be 3 hydrogens. But where am I going to put the oxygen? So to put the oxygen is going to be 1, 2, 3 again, right? I've got 3 carbons. The first one is full, the second one is like this, and then the third one, I need to have oxygen and 3 hydrogens. So it cannot have all those bonds because it must have only 4 bonds. So it means that one is OH, one hydrogen is with oxygen here, and then H here, and then H there. So you can see that all the 3 H's I have there on my condensed formula. So this one's become a primary alcohol. This is the primary alcohol. This is an aldehyde. Are we clear? Guys, are we clear between the difference of these two?
Yes, sir.
Yes, sir.
Okay, that is very important, right? To be able to read the condensed formula, right? We have to be able to read the condensed formula, right? We have to be able to read the condensed formula. And then the last one, we've got a structural formula. We have talked much about the structural formula. So this is the formula that shows all the bonds and the atoms in the molecules. So I will advise you to understand the structural formula before everything, right? So if you understand the structural formula, that's when everything is visible. That's when you can easily name the molecule, all right? It's not easy to name the molecule in a condensed formula. It's not easy to name the molecule in a molecular formula, right? The easiest way to name the molecule is when it's in its structural formula so that you see the positions and everything, right? Not just the number of carbons, not just the number of hydrogens, not just the number of oxygen, but where you can see exactly how they positioned. That's how you can start to name the molecule, all right? So I would say the most important thing is structural formula. Although you have to understand your condensed formula, you have to understand your molecular formula, but the most important thing is your condensed formula. CH3, just know that CH3 is the last carbon, All right, the last carbon is the only carbon that will have three hydrogens. If the carbon is in between, then it cannot have three hydrogens, right? A carbon with three hydrogens, it's a last carbon. All right, so for an example, if I've got C1, CH3, and then CH2, and then they might give a brackets and say CH3, CH3. So this one should have not been 2, it should have been 1. It should have been 1 here, something like this. And then CH3, and then CH, and then CH3. All right. What does this tell you? This tells you that this one here, it is only bonded with one carbon and it's in between, which means that this is a branch. Right? It automatically tells you that this is a branch because I see CH3. There is no way a carbon in between a chain will have three bonds. It has to be in the last carbon that will have three bonds, right? So this one, the longest chain is going to be the first one. You can see I've got the first one here. CH3 is fine. So it means that I'm done with this one. This one have only one hydrogen. So it's going to be C and then one hydrogen. All right, and then this one must have three hydrogens. So if I put it here, it won't be able, if it have three hydrogens, then okay, so there it is, it have got three hydrogens. All right, so this next one here, it have got one carbon, so one hydrogen. So where can it go? If I put it here, it will have one hydrogen, but it will have two spaces left, and then I'm only left with CH3, so it won't work like that. All right, it won't work like that. So let's see what else can we do. Okay, so this one was supposed to be true here. Yes, I think I made a mistake. Yes, that one was supposed to be true. Yes, so that it can have CH2 here, and then it means that the last one is going to be CH3. So it's going to be on top here, right? It's going to be on top there. All right, so it is, means that the longest chain is this one. So you can see that the longest chain is bent. So if I didn't want to have the longest chain that is bent, I would have said CH3, there it is, CH2, CH1, there it is, and then CH2, there it is, and then CH3, there it is. And then what I'm left with is this CH3 that will just come here and be my CH3 there. All right. So this one, because I saw CH3, CH3 has to be at the end, CH3 has to be at the end, CH3 has to be at the end. There is no CH3 in between the chain. Is that clear?
Yes, sir.
Okay. That is very important, right? So that is how you understand. You can take your condensed formula to structure formula. You have to understand that there can't be CH3 in between the chain. All right. And then the other thing that I wanted us to look at is isomers. All right. Is isomers. It went up there. Okay. Isomers, you still remember when we were doing those questions yesterday, I said no isomers for today. All right, no isomers for today. Okay, isomers. Isomers, compound having the same molecular formula but different structural formula. All right, isomers are the compounds that have the same molecular formula but different structural formula. Right, so we've got chain isomers, we've got positional isomers, and we've got functional isomers. Right, you still remember when I told you about the functional group, right? Okay, so now let's talk about the chain isomers. These have the same molecular formula but different chains. Example that I just gave you was which one? Was I started with that example. What was a butane and methyl propane, right? Butane and methyl propane. They are chain isomers because they've got the same molecular formula, right? They've got the same molecular formula. They are all C4H10, but because the chains are different, this one have got a branch, this one doesn't have a branch, so we call them structural isomers. Right, we call them structural chain sorry for that, chain isomers. Right, we call them chain isomers, right? So compounds that have got the same that the formula but different structural formula, yes, they call them chain isomers. These have the same molecular formula but different chains. So they it is in fact they've given us butane and 2-methyl propane, exactly what I've shown you there. All right, 2-methyl propane and butane. So that is our chain isomers. Are we clear about chain isomers?
Yes, sir.
Okay, and then now we've got positional isomers. Positional isomers, these have the same molecular formula, but the functional group is in a different position. So the functional group is the same, but just in the different position. So we call them positional isomers. So one example I can give you is butene. All right, is butene. This is butene. This is our butene. All right, this is our butene. This is our butene. All right, and then this one is butene, and then this other one is going to be what? It's going to still be butene. All right, but you can see that now the double bond is in between there. Right, you can see that the double bond now is in between there. So this one is but one in, right, and then this one is but two in. Right, so it's the same formula, same structure, but different position. All right, different position, so we call them positional isomer. So we've got propan 1 all and propan 2 all, and then we've got also ketone can also be isomers, right? Ketones can also be positional isomers. So this is our ketone. All right, this is our ketone. All right, this is our ketone. This is our ketone, and then the position you can see that is on number 2, and then this one doesn't have an isomer, so this one doesn't have an isomer, so let me make the one that have got an isomer. All right, but 1 butanone doesn't have an isomer, right? Yes. Okay, so they it is this one have got an isomer because this one here can be in position number 3 there, or someone can decide to put it in position number 2 there. Right, someone can decide to put it in position number 2 there. 1, 2, 3, 4, 5. So you can see that this one is butan butan what butan 2 1, right? Butan 2 1, and then this one is butan 3 1, right? So that is our that is our positional isomer. Are we clear about positional isomer?
Yes, sir.
Okay, and then now we have got functional isomers. Functional isomers, guys, there's only two pairs. If they want us to talk about the functional isomer of an aldehyde, it's going to be a ketone. Ketone and aldehydes are functional isomers, right? Carboxylic acids and esters are functional isomers. That is very important. That is the isomer that you need to understand, that you need to just know from heart. That's the only isomers, functional isomers that they're going to ask us about: ketone and aldehyde, carboxylic acid and esters. So those are the functional isomers. Why are they the functional isomers? Remember, the functional group of an ester, the functional group of an ester is going to be O, C, and then O, like this. That is the functional group of an ester. All right, and then the functional group um, of an what do we call this, carboxylic acid is also O, and then C, then O. Remember, but on the ester here we're going to have an H, not on the ester, on the carboxylic acid, remember it's OH there. All right, but you see that this functional group here is the same as this one. All right, the only difference is this H that comes ahead, right? So those two things are functional isomers. All right, they are functional isomers. ester and carboxylic acid. Ketone, I'm not going to talk much about it because ketone, we talked about it when we were doing ketones, right? When we were doing ketone and aldehyde, I told you that ketone and aldehyde are the same. It's just that the different on a ketone is that the oxygen is on the carbon, which is in between, in the middle. And then on the aldehydes, the oxygen is on the carbon that is either on the end or at the beginning, right? So that is the difference between ketone and aldehyde. They are functional isomers. All good.
Yes, sir.
Yes. So okay, let me just answer this guy. Nice one. Andisa, aka drop a color. Phone the jara la kufona na watu pana abade a drop a color. Uzambona zwa puteza ndiko tana mchekera. Sorry for that, right? Okay. So, um that's it, right? That is our isomers, right? That is our isomers. And then now can go to reactions. We are going to go to reaction. Can we start reactions today? Okay. Yes, we can start reactions today. We've got different reactions. We've got the names. We've got addition. We've got elimination. And then we've got substitution. So these are the three words that I want us to start with, right? Guys, I know you know English, right? There's no way you are English if you don't know English. You know what is to add, you know what is to eliminate, and you know what is to substitute. All right. Do we know that 10, or do we know how to add?
Yes,
You know how to eliminate, right?
yes,
Know how to substitute. So to add is to add something. Some if we have got 4 people, right? Let's say we've got a class of 15 people, right? We say we've got a class of 15 learners, and then we add 4 learners. How many learners are we going to have? We're going to have 19, right? And then we are going to have 19 if we add, right? So let's say now we've got the same class of 15 learners. We eliminate 4 learners. It means that how many learners we're going to have? So we removed 4, so we're going to have 11 learners, right? So that is just a remover. We eliminated, right? And then from the class of 15, let's say we substitute 4 learners. Substitute means we're taking out 4 learners and putting back in other 4 learners. Like for an example, let's say our class was grade 12A. All right, grade 12A can only hold 15 learners. All right, so it's going to hold from position 1 out to position 15 out of the whole grade 12. Right, so it means that if some of the learners, maybe 4 learners, they were in top 15, but in the next term they get out of top 15, it means that we're going to remove them. So which means that out of the learners that were out of top 15, so because there were 4 who went out of the top 15, 4 came into out of that top 15, so we removed those 4 and we add the new 4 that came into the top 15, right? So that is the substitution. Are we good?
yes,
Okay.
Yes, sir.
Yeah. Okay, so when we talk about addition, guys, can we add here? Can we add something here? Can we add something here? This is what? This is a methane. Can we add something on methane? Rusan, can we add something here on our methane?
I don't think so. And
Think
it's ethane, sir.
no, we cannot add anything because it's complete, right? There is no bond that is left. There is nothing we can add here, right? Every bond is just put perfectly. There is nothing we can do. We cannot add here. But can we remove something? Yes, I can remove this H2HCl, right, which is going to be hydrogen gas, H2, right? If I remove them, what is going to happen? It's going to be C, so it's going to be double bond here. So I removed two hydrogen, and then it became like this, all right? And then it's going to be plus H2. So I removed two hydrogens from our methane, so it became what? It became methane and hydrogen plus hydrogen gas or hydrogen molecule. Out clear? So this is what this reaction is what? Is elimination. I have eliminated. This is elimination, right? This reaction is going to be called elimination. I have removed something, and from our molecule, right? I've removed hydrogen from our molecule, so it is called elimination. Out clear?
Yes, sir.
Okay, so this one here, if I have our methane, right? If I have methane here, it means that I can add hydrogen. I can add hydrogen to make it back to methane, right? To make it back to methane, all right? To make it back to methane. That hydrogen just went in there, and then it became the methane again, all right? So this one is what? This one is addition. I've added. I remember now I had this one. I reacted it with hydrogen. It gives me methane. So it means that this one is just an addition. I have added. Is that clear? Addition and elimination. Is that clear? That should be very
Yes,
clear.
sir.
That should be very clear. All right. We remove or we add. All right. And then there is something that when maybe we have got this one. We've got one, two, and then this one here, and then plus H B R, or hydrogen bonding with bromine, like this. All right. So you can see that this one here is a saturated, right? It's a saturated, right? So if we are to add on this one here, remember we want to put this one. We want to put bromine into our alkene, all right? We want to put bromine into our alkene. So what will happen is that one bromine here, this bromine will leave here and come and substitute one hydrogen. Which hydrogen? We'll talk about that one later, all right? So it's going to come, our bromine is going to move here to come here, and then this hydrogen will move here to become an H2 gas. All right. So it means that the product is going to be 1, 2, 3, like this. And then one will have Br here, bromine will come here, and then this is H, 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 and then this is H. So what's happened here is that the bromine was the hydrogen was replaced by the bromine, so it was substituted. So this is a substitution reaction. Are we good?
Yes, sir.
So that is the main words. The main word: addition, elimination, and substitution. Right? Addition, we cannot add on the saturated hydrocarbons. Remember this our terms that we named them: saturated and unsaturated. Saturated hydrocarbons, right? Saturated hydrocarbons. We still remember saturated hydrocarbons, no multiple bonds. Multiple bonds. And then this is for saturated, right? So for unsaturated, we've got multiple bonds. So either we're going to have a double bond or a triple bond. They are unsaturated. So there is no addition reaction on a saturated molecule, but unsaturated molecules can undergo addition reaction to become saturated. All right, unsaturated, remember, saturated, this is saturated molecule. All right, this is saturated molecule. So there is no addition that we can do here because every bond is just having something. All right, so but it means that it can go elimination to become what? Elimination to become unsaturated hydrocarbon. All right, to become unsaturated hydrocarbon. All right, and then unsaturated hydrocarbon can undergo addition to become saturated hydrocarbon. All right, so that is one thing that you should take that you should always understand. All right, and then elimination is just usually happens on the what do you call this, on the saturated, and then it will still be saturated, right? There is no double bond that is going to be formed because there is nothing that was removed or added. We just substituted something. All right, sometimes we'll substitute hydrogen with OH, sometimes we'll substitute so many different things. We'll understand them once we go there. I just wanted you to understand the reactions, right? The reaction, right? I just wanted you to understand the reaction, elimination, addition, and substitution. That's the first thing that I wanted you to understand, right? So remember, um, what is this? We've got hydrogen, H2, right? And then we've got H2O, which is water, and then we're going to have HBr, which is hydrogen and halogen. HBr or HCl or HI, HI. So it's bromine, chlorine, iodine, and what? On group number 7, what are those elements? Halogens. Is bromine, chlorine, iodine, and what? I think there are 4. Is there anyone who has got a periodic table next to them?
So isn't it fluorine?
Fluorine, yes. HF, yes. So those are these ones we call them hydrohalogens, right? Hydrohalogens, right? All these we call them hydrohalogens. And then this one, Br2, is just a halogen, and then Cl2 is just a halogen, and then I2 is just a halogen, and then F2 is just a halogen also. So these ones are halogens, right? These ones are halogens, right? So this one is, yes. So, and also we're going to have oxygen. So oxygen, I will talk about it later. I don't want to go to combustion now. All right. So these ones here, if we add hydrogen, all right, if we add hydrogen, all right, we call it hydrogenation. Hydrogenation. All right. If we add hydrogen, we call it hydrogenation. If we subtract hydrogen, we call it dehydrogenation. Right? Addition of hydrogen, we call it hydrogenation. Elimination, removal of hydrogen, we call it dehydrogenation. Right? And then for water, addition of water, we call it hydration. That doesn't have hydro, it doesn't have D, it's just called hydration. Hydration. You know the spelling. Me and spelling, we are not we are not friends, right? Yeah, I think it's hydration. Yes, I think it's the correct one. Hydration. All right. Hydration is the addition of water, and then removal of water is called dehydration. Dehydration. Right. Dehydration. Right. Dehydration. and hydration is for water, right? Addition of water, hydration. Removal of water, dehydration. Addition of hydrogen, hydrogenation. Addition of removal of hydrogen, dehydrogenation. To have a O for hydrogen, right? For hydrogen to have an O. For water, it will never have an O, right? Just say dehydration and dehydration and hydration, all right? So that is the difference. And then when we talk about hydrohalogens, right? So addition of hydrohalogen is going to be hydrohalogenation. Hydrohalogenation, right? And then that is the addition. The removal of hydrogen and halogen is called dehydrohalogenation. All right. So we've got addition of hydrohalogen and removal of hydrohalogen, right? So we've got hydrohalogenation and dehydrohalogenation, all right? And then we've got the addition and removal of just a halogen without a hydrogen, which is called a halogenation, or dehalogenation. All right. So those are the easy things that I need you to understand with these reactions, right? We're still going to talk about reaction condition, what needs to be there for addition reaction to happen, for hydrogenation to happen, and all the stuff, right? But I need you to understand these basics, right? Remember, hydrohalogens are very important. Halogens are very important. Water is very important. Hydrogen is very important. Oxygen, guys, oxygen will just make a reaction called combustion, right? For oxygen, it's just going to be a combustion. All right. For oxygen, it's just going to be combustion. Addition of oxygen is going to be combustion. This is called a combustion. All right. Combustion. What will combustion form? Every time you add hydrogen on a what do we call this? On this on these organic molecules, right? Addition of hydrogens will form combustion. Combustion will just release two things. It is just going to be carbon dioxide and water, right? The product is going to be carbon dioxide and water. That is a complete combustion, which is good, right? Which is something that we want. Whenever we want to undergo, we want to do combustion, we must make sure that it's a complete combustion, because once it becomes incomplete, it will release a very dangerous gas, which is called carbon monoxide, right? If the combustion is not complete, it is going to release carbon monoxide. If it's complete, it's going to release carbon dioxide. Carbon monoxide is a poisonous gas which doesn't have a smell, which does you cannot feel it, you just die, right? You just die a quiet, non-painful death, right? You just die a quiet, non-painful death. You just lose it, right? That is how carbon monoxide kills people, right? You die without any pain, you just collapse, and then that's it. All right. Why does it do that? It reacts with the oxygen. The only danger that it has is that wherever it goes, it finds oxygen, it reacts with it. So the little oxygen that you have inside your body, it is going to react with that carbon monoxide, and then you will be left without any oxygen, which means that your body won't be able to function. Then that's it, right? So carbon monoxide is very dangerous. Reacting oxygen and a hydrocarbon is something that you should take very seriously, because once it's happening, you should make sure that the combustion is complete, because once it becomes incomplete, then danger looms, right? That is very dangerous. Incomplete combustion is very dangerous. What is combustion? Combustion is the reaction of oxygen and hydrocarbon, right? So if it becomes incomplete combustion, then that's very dangerous. All right. So I can just give you an example of combustion. So combustion is going to be let me say CH3, C3H8. All right, C3H8 reacting with oxygen, and then to form what? To form, reacting with oxygen. Right, reacting with oxygen, the product is going to be the same. It's going to be CO2 plus H2O plus energy. Right? So it's carbon dioxide and carbon and hydro and water is going to be the product, right? So the only thing that will be left for you to do is just going to be to balance the equation, right? Remember, this one is C3H8, right, plus O2 forming CO2 plus H2O plus energy. All right, so which means that this one here, the oxygen, is it oxygen balanced? No, it's not balanced. Right, it's not balanced, but the most important thing for us to balance is the hydrogen first. So is the carbon first. So if I put 3 here, carbon is now balanced. And then how many hydrogens do I need to have? I need to have 2, and then I add 8 here, so it means that I need a 4 here. So hydrogen and carbon are now balanced. So the only thing that is not balanced is oxygen, and we see you have got oxygen standalone here, which means it's easy to balance the oxygen, right? So I've got 6 carbon oxygen here, I've got 4 oxygen here, which means that all in all I've got 10 oxygen on the right, so it's just going to be 5 here. So this is your combustion reaction. All right, so that is very straightforward. I think it comes with 3-4 marks, right? If it does comes with 3-4 marks, they just tell you that methane gas react with oxygen to form a complete combustion. Sometimes they will say incomplete combustion. So this one is a complete combustion, right? This one is a complete combustion. So when we talk about incomplete combustion, incomplete combustion is going to be what? It's going to be C3H8 plus O2, and then forming CO, carbon monoxide, plus H2O plus energy. All right, so this is an incomplete combustion. All right, this is an incomplete combustion. All right, so this one here, if we are to balance it, it means that H2O is going to balance C by 3 here. So C is now balanced, and then H is not balanced. So this one was supposed to be 8, right? Supposed to be 8. H is not balanced. So if I put a 4 here, going to be a challenge, right? It's going to be a challenge because if I put F4, then carbon is balanced, hydrogen is balanced, but O is not balanced. You see, O, I've got 7 O's, and then here I've got this one here. All right, so it means that I am going to do what? I have to multiply everything by 2 so that it becomes an even number here, because I cannot balance with this even number with an odd here. All right, just to be all even numbers. All right, so I'll just multiply everything by 2. So it's going to be 2 C3H2 plus O2 is going to be the last thing for me to balance, plus 6CO2 plus 8H2O. Right? So there we are. All right, there we are. So now hydrogen is balanced. This is 3, right? Yes, carbon is 6. Carbon is 6. Yes, hydrogen is 2 multiplied is 16. Hydrogen is 16. And then now the only thing that I need to balance is oxygen. So oxygen, I've got 8, and then plus 12, which is going to be 20. So just going to have 10 here. So there it is. That is the balance. Incomplete combustion, right? It's not CO2, it's CO here. So I've made a mistake there. It's not CO2, it's CO, because it's an incomplete combustion. All right, so it means that here to balance, I can't use a 10 there. I'm going to use what? Okay, I've got 6, and then I've got 8, I've got 14, so it's going to be 7 here. So there we are. That is the incomplete combustion. All right. Complete combustion, it will form CO2 and water. Incomplete combustion, CO and water. All right. But I haven't talked much about reactions. That is the next stop. Right. We are going to finish with the reactions tomorrow. All right. We're going to finish with the reactions tomorrow. Guys, please just make sure that you go and watch those videos. I told those ones that we started with, I told them that, organic chemistry is the easiest topics if you start with it, but if you join it in between, you will think that whatever we're saying here, it is a very big thing. It's not a big thing, guys. If you started with it small, this thing is the easiest topic, right? I know some of you are starting to worry now, are starting to stress out that this thing that I'm going to have to answer in grade 12, yes, this is what you're going to answer. And then this is something that I can promise you that we all going to be able to answer this kind of question. It's a big topic. It have got 50 plus marks in our paper one, paper two. So just think about 50 marks in paper two. You already passed, right? By just knowing this topic throughout, you already passed your grade 12 physical science chemistry, because once you've got 50, that you know that you can only lose maybe 5 or 6, right? You can only lose maybe 5 or 6. You can understand all these things. They are going to be very, very easy for you, right? So let's call it a day, guys. We'll see each other tomorrow. I will just add this video at the bottom there on the other videos, the 3 videos that I have. I told you the mistake that is on the last video number 3, when I was talking about the Easters, right? When I was talking about the Easters, I used OH here instead of O, right? Instead of O, I return OH here. So I've just rectified it. It's just a double, it's supposed to be a double bond and O for an Easter. So I said an Easter was supposed to be something like this, right? I said an Easter was something like this. And then which is not correct, right? Which is not correct. This is not an Easter. An Easter is supposed to be O here, like this. Right? That is our Easter. So let's call it a day, guys. We'll see each other tomorrow unless we have got questions. Do I have any questions? This video will be up on the on that link that I've sent you of 3 videos. This is going to be the 4th lesson, right? This is going to be the 4th lesson. It is about what? It is about the we started with the representing organic compounds. When I was starting to explain the difference between molecular, condensed, and structural formula, then we went to isomers. I told you about isomers, and then we started the introduction to reactions, right? Elimination, addition, elimination, and substitution. So yeah, for now, let's call it a day, guys. We'll see